sketch the curve f of x is sine of 2x. How to get sine of 2x from just sine of x? This 2 implies horizontal contraction by factor of 2 with y-axis invariant. Notice that it's contraction. If you want to say in terms of stretch, it's stretch by factor over half. And we need from 0 to pi, so usual sine looks like this. One period it's from 0 to 2 pi, but since it's horizontal contraction by factor of 2, it means every point becomes 2 times closer to y-axis, so this point becomes just pi. So from 0 to pi it's just such a curve, and y changes from -1 to 1. The next, hence sketch on a separate diagram the graph of g of x is cosecant of 2x. X is from 0 to pi, including endpoints, clearly stating the coordinates of any local maximum or minimum points and the equations of any asymptotes. What is cosecant? Cosecant is 1 over sine of 2x here. And if it is given a function f of y, and we need plot what 1 over f or 1 over y, it's a usual reciprocal function, and it's useful when a function is plotted or when graph of just a function is given. So it's very useful to plot reciprocal. And how to do that? Where a function has zeros, x-intercepts, for reciprocal it becomes it's 1 over y value, so 1 over f, 1 over y. But if y is 0, we can see that it becomes 1 over 0, it's infinity, and such points become what vertical asymptotes. So we can see that there are vertical asymptotes at 0, pi over 2, and pi, and we can write it as asymptotes are x is 0, x is pi over 2, x is pi. And if we have some specific points, if we know some coordinates, we can calculate directly coordinates of a reciprocal. So here we can see that this point is pi over 4 and 1, so it becomes pi over 4, 1 over y, so 1 over 1, 1. So, and actually this point remains the same, and we can see that it's a local maximum here, so definitely it will be a local minimum here, and why it becomes local minimum, because if you continue to plot the graph, you can see that when we tend to 0 from the right, or when we tend to pi over 2 from the left, we can see that y becomes very small but positive, and 1 over y it becomes very large and positive. So for the reciprocal, y values tends to plus infinity, and this graph must be, or this curve must be symmetrical, and hence we can see that pi at x is pi over 4, there is a local minimum, and similarly this point is 3 pi over 4, and y is -1, and it becomes 1 over y, 1 over -1, also -1, so this point becomes 3 pi over 4 and -1. And when we tend to pi from the left, or when we tend to pi over 2 from the right, we can see that y becomes very small but negative. 1 divided by very small but negative, it becomes very small, but it becomes very large and negative, so it tends to negative infinity, and also it must be symmetrical. And we need from 0 to pi, but in general such curves continue up to plus and minus infinity. So it looks like this. And we can see that there are no horizontal asymptotes, and local maximum is at 3 pi over 4 and -1, and the local minimum is at pi over 4, 1. Next, shows that tangent plus cotangent is 2 cosecant of 2x. And its identity, how to prove the identity, we can transform the left hand side up, we get that it is equal to the right hand side, or we can transform the right hand side up, we get that it is equal to the left hand side, or we can transform both sides up, we get that two same expressions. Definitely in general we can use that tangent is sine over cosine, cotangent is cosine over sine, and we can try use these. So it becomes tangent plus cotangent of x, it's sine over cosine plus cosine over sine. In general there may be another ways how to prove this. So, and definitely what is the next step? Definitely common denominator, it becomes sine cosine, sine squared plus cosine squared, and we can see that sine squared plus cosine squared is the main trigonometric identity, it's 1, so it becomes 1 over sine times cosine. And actually what do we need? We need cosecant, it's 1 over sine but over double angle, and we know that sine of 2x is 2 sine cosine, so we can see that we need 2, so we can multiply numerator and denominator by 2, and we can see that it's directly sine over 2x, so it's 2 over sine of 2x, which is 2 cosecant of 2x as required. D. Hence, or otherwise, find the coordinate of the local maximum and local minimum points on the graph of y is tangent of 2x plus cotangent of 2x. Definitely it will be useful to use this identity, and we can see that but notice that identity is for some angle, but since there is 2x on the right hand side, we can see that angle becomes 2 times larger, so this becomes 2 cosecant of 4x. And we should consider a graph of 2 cosecant 4x, and definitely we can use the previous graph, which is y is y is sine of 2x, it's y is just cosecant of 2x, but now we need 2 cosecant of 4x, and notice that it becomes x becomes from 0 to pi over 2, and 4x with respect to 2x, it's horizontal contraction by factor of 2. and every point will be 2 times closer to y-axis. Or if we consider, for example, pi, there will be 2 more, or there will be such a picture again. But since we need up to pi over 2, and since it's contraction by factor of 2, this point becomes pi over 2, it becomes 3 pi over 8, pi over 4, pi over 8. Oh, let me write here. So it becomes pi over 8, pi over 4, 3 pi over 8, and pi over 2. And these two, it's what? It's vertical stretch by factor of 2 with x-axis invariant. Every y value becomes 2 times larger. So this point becomes, y coordinate becomes 2, this becomes negative 2. And hence, for this function, local maximum is at 3 pi over 8 and negative 2, and local minimum is at pi over 8 and negative 2. The next, find the solution of the equation cosecant of 2x is 1.5, tangent x minus 0.5. And definitely, since it's set, we should use the previous result. Usually it's more useful. And one more about the previous. In general, how to find local maximum and minimum. Another way, it's what? It's to find derivative and equate it to 0. It's a general technique how to find maximum or minimum. But definitely, since it's a set, definitely it will be more useful use the previous result. And the next, so find the solution of the equation cosecant of 2x is, and since it is given this identity, and we can see that if we substitute this for cosecant, we can get an equation in terms of tangent only, and it can be easily solved. But since this identity is for 2 cosecant, we can just multiply each by 2, each term by 2, and 2 cosecant, it becomes what? Tangent plus cotangent, tangent plus cotangent, and cotangent is 1 over tangent, and its left hand side is equal to 3 tangent minus 1, and this tangent to the right, so it becomes 2 tangent on the right hand side, so it becomes 1 over tangent is 2 tangent minus 1, and multiply each term by tangent, we get the next. 1 is 2 tangent squared minus tangent, and we can see that it's the usual quadratic with respect to tangent, so we can rearrange it and get 2 tangent squared minus tangent minus 1 is equal to 0. And it's question without a calculator, it's paper 1 question, so we can denote tangent to be t, so let tangent be t to be more clear, and we can see that it's quadratic equation. And using discriminant, since a is not 1, it may be not useful to use sum and product rule, or you may try as you like, but I will use discriminant. So discriminant is b squared minus for AC, so b squared 1 minus 4 times 2 times negative 1, and it's 9, root of d is 3, so t One is minus b minus root d over 2a, so it's negative a half, and another root is 1 plus 3 over 4 is 1. So we get the tangent is negative a half, or tangent is 1. And notice that we need x from 0 to pi over 2. 0 to pi over 2. And how to solve tangent to the number? We use just a formula. This argument, so x is arctangent, or inverse tangent of 1 plus pi k. Pi is period of tangent, k is any integer. And arctangent of 1 is pi over 4, so pi over 4 plus pi k, it's general solution. And we can see that when k is 0, x is pi over 4, it's a solution. And when k is 1 or greater, x is not from a given region, so there are no solutions. And when k is negative, also x becomes negative, so no solutions. And let's consider this. X becomes arctangent of negative a half plus pi k, general solution. It's arctangent of negative value, it's odd function, so it's minus arctangent over half plus pi k. And notice that I cannot say what is arctangent over half, because we know only without a calculator we know only for 30, 45 and 60 degrees. But since we need x to be from 0 to 2 pi, what is arctangent of a half? Since tangent is increasing function, and arctangent of 1 is its tangent. Arctangent looks like this, and I mean the next. So arctangent of 1 is 45 degrees, or pi over 4, and arctangent of a half, it will be an angle which is smaller than 45, because tangent looks like this, and 45 is here, 1, and if we consider y to be 0.5, it will be some value which is less than 45 in degrees. So it's some angle which is less than 45 and minus, so when k is 0, it's some negative value which is not from the required region, and when k is 1, when k is 1, it becomes pi minus angle which is less than 45, and definitely it will be greater than pi over 2, so there are no solutions here. But notice that if it's paper without a calculator, and if there would be some solution, you should leave arctangent. So no solutions here. So there is only one root, x is pi over 4. And that's all for this question.